So we're going to be going over assignment 3. So essentially the aim of this assignment, I'll show you here, is we're basically going to be creating like an image upscaler, but we're going to be using a convolution autoencoder. So we'll be training a neural network just to, turn the image from like that is a 28 by 28 to at least 56 by 56. So this implies that we're going to upscale an image, aka making it larger and a little bit clearer. And so this is basically the set of instructions that we have to do for this assignment. And we had to specifically use PyTorch and not TensorFlow, which is fine. So I'm going to go over the code. Essentially right now I'm processing the code and it's taking long, but I've already run it before and saved the results. So I'll show you what the results look like. But first and foremost, we went ahead and just imported some packages that we need to run our code. And then I went ahead and just mount the Google Drive and also loading the data, just so that way we can access the image data source from the Google Drive. Now, obviously, the training data set is found in the train folder, and then this is the test path, the testing dataset path, and I've stored it into a variable called test_folder. Okay, so now we're moving on to this part of the code. So this right here is I'm creating a class called load and preprocess dataset, and you guessed it, the idea, the creating this custom class, we are basically just loading each image from the folder and then converting it to a grayscale. And we're going to be creating like two versions. Essentially, we're creating a small version that is like 28 by 28, and that's going to be serve as our input. And then we're going to have another version called large, in this case here, specifically called a big image. And so that is like the larger version, which is 56 by 56. And that's going to be served as our target output. And so the idea of it is that, first of all, this right here is our constructor. And so in our constructor loads the image files from the Google Drive dataset directory. So that just helps instantiate those things. And then this function right here just returns the length of the number of images. And then this right here, this basically returns the small and large images like I've mentioned. Okay. So now we're moving on to setting up the transforms. So these transforms, we just resize the images to the sizes that we need. So with the transform _small, that's gonna be serving our 28 by 28 for input, and then the transform _big is just gonna be serving as our 56 by 56 output. So basically, we're converting them into PyTorch tensor so the model can use it because it requires it to be in that format. Great. And so this part of a section, ideally what this does is just loads the data. And when we create the training and testing data sets, we have to wrap them around like data loaders because that helps us like batch and shuffle the data during training. So that's pretty much what this guy does. And so now we're moving on to the class autoencoder. So here we're just creating a convolutional autoencoder class just to help us to compress and reconstruct the image. And here we have a couple of things. One we called on super, and then we also then do the self.encoder and then self.decoder. So by the way, the super class, it just calls on it inherits the autoencoder, and it just calls on the constructor. Anyway, the dot encoder and dot decoder, they serve two different purposes. The encoder essentially compresses the image by reducing its spatial dimensions, but the decoder basically that it just tries to rebuild or upscale the image just to a larger size. Let's see. And then we also define like the forward pass function here. And that calls on the encoder and decoder and then returns itself. So what I do want to mention with this area though is that we are using the Con 2D and the Max Pooler layers for the encoder part, which you'll see right here and here. And our activation layer is we're using Relu. And basically we're trying to reduce the size. Then you see that right here in the decoder we use the Convo Transpose 2D and we use the up sample layers just for the decoder just so we can again enlarge it. Okay, so now we're just setting up the training. We do that by moving the model to the GPU if it's available for faster training. But then afterwards, we're going to just go ahead and print out the model architecture summary. Okay, and then we use the binary cross entropy loss and the atom optimizer. Okay, and then after that, we're going to begin training the model. So in this case, we're going to be training the loop to run 20 epochs. And essentially that each batch, the model basically tries to predict the upscaled image for the smaller input. So to do that, we actually have to compute the loss between the prediction and the ground truth images. But once we do that, we actually have to update the weights of the model. And to do that, we have to use the backward propagation. But then afterwards, we went ahead and saved the model after each epoch, just so we have it there. So that's what this does. Okay, we're still... Okay, so now we're actually going to see how well the encoder performs on those test images. And essentially, we only break out after the first batch is displayed. So the point of this is just to visualize the results. So after we train, we want to switch the evaluation mode and then just grab the first batch, which is like the first 5 sample results, and then we run them through the model and plot them. So we're going to get back 3 things. We want to first get the original input, which was our 20 by 20. Then we're going to get the predicted, which is the 56 by 56, which is the upscaled output of the model. But then we want to return also the ground truth, which is also 56 by 56. So that's that. And then we went ahead and just displayed the output. So again, we're expecting to have like the 5 predictions side by side. And so we want the generated model, the image, to be similar to the ground truth, because then that's how the only way we know the model is working. And so essentially, I'm going to show you the results of what we would end up getting. And this, let me, so there we go. That would be the output. And so basically this code just builds and trains the convolutional autoencoder, specifically in PyTorch. And the idea is to take a low resolution image and then making it larger. So, and also making it a high resolution version of it. So you can see that, you see the first, this is what we first get back, and they're really blurry, but then you'll see that our final product would be of a more of a high resolution version of that image. Alrighty, and just want to show you what we would get. it's going to run the epoch up to 20, but like I said, since it's taking forever to load, essentially I'm just printing out each epochs and its loss function, and it will go up to 20. So yeah, that is pretty much for this code.